taken up the first chapter of chemistry notebook, that is states of matter. Now, before starting, I would like to ask you that what do you understand by the word matter?
Matter as in substance.
Any substance, that's it?
Something with more details.
Sorry?
The matter, like states of matter, is divided into three parts: solids, liquids, and gas.
Okay, no, that's clear, that's right. States of matter are of three types, but what is the meaning of matter?
Matter, is it not like a substance? Is it like something objects are made of?
Okay, anything which occupies space. What is, what is matter?
Anything that occupies space?
Yeah, anything, okay, which takes up any sort of space, that is called matter. Okay, for example, this is a pen. This is taking up a certain amount of space in this environment, so it is a matter. Okay, this is a phone. It is taking up some space, so it is a matter. I am taking up some space, so I am also a part of matter only. Clear?
Yeah.
All right. Now, this matter is divided into three parts. It is in three forms. States means different forms. So, what are
Yeah.
those three forms of matter?
Solids, liquids, and gas.
Yeah, you can say states or forms. They are solids, liquids, and gases. Now, we have divided matter into three categories. What is the basis of this division? How will you classify what is a solid, what is a liquid, or what is a gas? How will you differentiate between these three states?
They usually occupy different temperatures, solid being the cooler one and gas being the one with the higher temperature.
Okay, so on the basis of temperature.
And solids have a
Okay,
fixed
we'll take the
volume and
very
a fixed
basic.
shape. Liquids have a fixed.
Yeah, please say again.
Liquids have a fixed volume but not a fixed shape, and gases have nor a fixed volume nor shape.
All right. Okay, nice. Now we'll take the very basic line of division, which is how the molecules in these states are packed. Okay.
Yeah.
So, sorry. Yeah. If we talk about solids, then the molecules in solids are compactly packed. Compactly packed molecules. Now, what do you understand by compactly packed? It means the molecule will be placed very close to each other, right? This will be the sort of arrangement in solids. They are very closely placed to each other, right? So that is why when these molecules, they are placed very closely to each other, we say that solids have a fixed shape. Okay? Clear?
Yeah.
Yeah. Now
Miss, sorry to interrupt, but I already covered this chapter of solids, liquids, and gases with the last teacher. Today, the OP messaged me talking about how they'll start Unit 4, which is organic chemistry.
all right. Actually, I was told that I have to start with this chapter only. Just allow me 1 minute and I'll confirm and I'll come back to you. Okay?
Okay.
Yeah. Soumya, am I audible?
Yes.
Yeah, Soumya, am I audible?
Yes.
Just a second, sorry. Yeah, I hope I am audible, Soumya.
Yes, miss.
Okay, so what we'll do is, as you said that you've completed the chapter already, so you're aware of the concepts of the chapter, right?
Yeah.
Okay, so I'll take a brief test of that, okay? Just to check that how much concepts are clear. Fine?
Okay.
All right. Just allow me one moment. Okay. So can I start? I'll start with brief MCQs, okay?
Okay.
All right. So when the solid directly changes into gas form, what is that process called? Or what is that
Sublimation.
term used for? Used.
Sublimation.
Sublimation. Okay. Now, which state of matter has the weakest forces between its particles out of the three given states of
Gas.
matter? Yes.
Gas.
Okay. All right. Now, what causes a solid state to change into liquid state?
Melting.
I'll give you options. I'll repeat the question. What causes a solid state to change into liquid state?
Melting. The temperature increases
Increases or decreases?
from a solid to a liquid. The temperature increases.
Okay, so you have a block of ice.
Hmm.
You want to convert it's in solid form, right? You want to convert it into liquid water. How will you change that? By increasing the temperature
You
or
have
decreasing the
to
temperature?
decrease the temperature past its melting point.
Correct. Okay. Oh, all right. Okay, so how will you define the state of oxygen?
Oxygen at room temperature is a gas.
Correct. Okay. Now, can you define the following terms? Melting point. What do you mean by melting point?
Melting point is the temperature from which a substance changes from solid to liquid.
Okay, the temperature from which any substance changes from solids to liquids. Can you give me the example of this?
The melting point of water is 0 degrees Celsius.
All right. Now, how will you define freezing point?
The freezing point is the point of a substance where it goes from liquid to gas. Sorry, liquid to solid.
Yeah.
And isn't it the same temperature as the melting point?
Yeah, it's vice versa because
Yeah.
in freezing we are changing the state from liquid to solid, while in melting we are changing from solids to liquids.
Yeah.
Okay. Okay. Now we have two different ways by which we can change liquid state to gas state. We have two ways to do this. Can you
Boiling and
define these two
evaporation.
ways? Correct. That is boiling and evaporation. Can you define both of them?
Boiling is when the substance reaches the boiling point, like for water, it's 100 degrees Celsius. But evaporation, it's when they change states, but it's not necessarily at the boiling point.
Okay. What happens to the particles when you boil the substance? What happens to the intermolecular forces between the particles of solid when you boil it or a liquid when you boil it?
The intermolecular forces are weak during boiling because the particles of the gases are far apart.
Okay.
Miss, could you actually explain the difference between boiling and evaporation? Because I think I have a doubt in that.
All right. Okay. One second. Okay. So what happens in boiling? When you heat a liquid, then the particles start moving very fastly. Okay. And all the forces of attraction between the particles of a liquid they start to scatter here and there. Okay, the movement is very rapid.
Yes.
Rapid movement between particles of liquid. Okay, there's a rapid movement.
Yes.
Now, the stronger the force of attraction between the particles means the more the strength of the attraction forces between the particles, more will be the boiling point. Now, why? See, we'll take an example. Suppose you have a solid, this is one substance, and the particles are very closely packed. Now, what you have to do? This is a block of ice. Okay, we'll consider that this is a block of ice. You are providing heat to this, correct?
Yeah.
Now, what will that heat do to the particles? It will break the forces of attraction between these particles, and they will start moving apart from each other like this, correct? Now, if we increase the temperature, we provide more heat, then what happens? The particles will move more
Even
far away
further.
from each other, right? Yes or no?
Yes.
So if the forces of attraction between the particles is more, the strength is more, you need to provide more heat to break them, to make them move apart from each other, right? You're providing more heat. The amount of heat is increased, na? Because the particles are compactly packed. You have to break them to make them move away. So to break this force of attraction, you are providing heat. So more the strength, more heat is applied to break the strength, correct? Are you getting or not? You can just clearly tell me that, ma'am, I didn't understood. Please explain it again.
Can you explain again?
Okay, no problem. So what is happening? Okay. Let's take theoretical example first. You have a block of ice, right?
Yeah.
You take it out, place it in your room, place it in a bowl, and put that bowl in your room. So the temperature of the room is more than the temperature of the refrigerator, right?
Yeah.
The temperature is increasing. So the forces of attraction between the particles of that ice block will start to break because we are providing it heat, correct? So the ice will melt down in a certain amount of time, correct? Now, let's say that the time taken was 30 minutes. At room temperature, when you're melting that ice at room temperature, it is taking 30 minutes to convert into liquid. All right? You seem a little confused. Are you not getting what I'm trying to explain you?
Yes, I'm getting it. I'm getting
it. Okay, all right. Now, if you take the same block of ice and place it on a gas stove, okay, will it melt more quickly or not?
Melt more quickly because more heat is being provided.
Correct. You've placed the block of ice on a gas stove, means more heat is applied, so it will melt more quickly. The time will decrease. Now let's say it converts to liquid in only 10 minutes, right? Now we took two examples. Same block of ice was taken. It was melted in two ways. So we are converting the solid ice into liquid water. Same ice block is taken, but two different methods are there. Can you spot the difference between the methods?
One is faster than the other.
Why? What is making it faster?
Because the heat on the gas stove is higher than the one in the room.
Sorry, say again.
There's more heat in the gas stove than it is in the room.
Correct. More heat, which means you have applied more heat or more temperature. The temperature was more when you placed the ice block on gas stove as compared to when you placed it at room temperature, right? So here the heat was less as compared to when the ice was placed on gas stove, correct?
Okay.
So that only we were discussing about that to when the particles are, they have stronger force of attraction. In order to break them, you need to apply more heat, right?
Right.
That was the concept of boiling. Clear?
Okay.
Okay, just you can just let me know freely that have you understood or not. I'll explain it again
Yes,
twice,
I
thrice.
understood.
Okay?
I understood.
Okay, now what happens when you cool the gas? If we talk about gas, this was about solids and liquids. Now, if you talk about gas, when the gas is cooled, then the particles they start to move slowly, right? And the forces of attraction between them start to hold it together, right? It comes together. The attractive forces between the particles bring them closer. And when this happens, this is gas, right? Particles are far away from each other. If I bring these particles comparatively closer, what is this change of state? This was gas. What is this state now? Because the particles
Liquid.
have become closer. Correct. This is liquid. All right. So this goes for in case of gases. This is called condensation. What is this process called?
Condensation.
All right. Now, if we come to evaporation, if I ask you that, what do you understand by evaporation? Just a basic definition of evaporation.
Evaporation is the process from which a liquid turns into a gas.
A
It's
liquid,
one of the methods.
okay, a liquid turns into a gas. Can you give me an example?
When you're taking a shower and you use hot water, the water will evaporate off your skin.
Sorry.
When you're taking a shower with hot water, you can see the water evaporating from your skin.
Okay, all right, all right. Correct. Now, what happens when we talk about evaporation? Then, sorry, the liquid is changing into gas form. Now, when you again here also we are providing heat only, but the difference is that it's uneven supply of heat when you talk about evaporation. Uneven
Uneven
supply
supply.
of heat. Now, what do you understand by uneven supply of heat? So what happens? Yeah, tell me.
Not the whole substance as a whole doesn't get the same amount of heat. So some parts are warmer than others.
Correct, very. Now, what are these parts? Suppose this is a pan. This is a liquid which is set to boiling. Okay.
Okay.
Now there will be some particles which will get more heat. So the temperature difference between the particles will be different. What will be? The temperature difference between the particles of liquid will be different. Correct?
Yeah.
Are you getting my point?
Yes, I'm getting it.
Yeah. There will be a temperature difference. Now, what is this temperature difference? Some particles will be at a lower temperature. They are getting less heat. Some are getting more heat. Some are getting medium amount of heat. Okay. Now, what will happen? The particles which are getting more heat, that heat will give them some sort of kinetic energy which will allow them to break the forces of attraction. Means that heat is so much more that they can break the attraction forces with the other particles. They will get separated with the other particles and they will move away. They will escape the surface because the amount of heat was slightly more than the other particles in the liquid.
Yeah.
Right, of the liquid, sorry. So these particles will escape the environment. They will overcome the forces of attraction and they will break away to form gases. So if you place a lid here on top of this pan, or this whatever this pan is, yeah, pan. So these particles will move away because the temperature is higher and they will convert into gas. They will escape the environment. These particles will convert into gas and the remaining particles will stay in the liquid form only.
Okay.
So in the same liquid, two states are there. Half is liquid because the temperature difference is there. Temperature is slightly less. And some particles have converted into gas. Why? Because the temperature provided to them was more, due to which they escaped. They broke the forces of attraction with other particles. They got separated. Correct?
Yeah.
And this got converted into gas. Okay, Soumya, please turn on your camera.
Yes. Yes.
Okay, we can interact in a better way if your camera is turned on. Okay? All right. So have you understood this concept?
Yes, yes.
Okay. All right. Okay. So can I continue with the questions part?
Okay.
Is there any other doubt?
No.
You sure you've understood both the things clearly?
Yes, yes.
Okay. All right. Okay. So can you define the term sublimation?
It's the process from which a solid directly turns into a gas.
Okay. A solid is directly turning into gas. Can you give me an example?
In some special substances. I don't know any from the top of my head.
Okay, okay, no problem. Have you heard of naphthalene balls?
I don't think so.
Okay. What can be other example of sublimation? These are also called, if you heard of camphor balls. Have you heard of them? Camphor balls?
Yes.
Okay. Have you heard of acetone?
Yeah.
All right. Okay. So this is an example of sublimation. This solid directly changes into gas state due to application of pressure. Okay. The pressure difference is so much that the middle state liquid is totally skipped and solids are directly converted into gases. Now, if I convert this process in the opposite way, if I carry out the process in the opposite manner means converting the gases into solids directly. What is that called?
Desublimation.
Desublimation. And what is other word for this process?
I forgot.
Okay, no problem. Desublimation, or it's also called deposition. Okay.
Okay.
So basically, this is the reverse of sublimation. Clear? Okay. Now we come to the next term, which is diffusion. Can you define diffusion?
Diffusion is the net movements of when particles move from an area of high concentration to an area of low concentration.
In which state is this process occurring?
In fluids, so liquids and gases.
Okay. Can you give me an example of diffusion?
When we use air spray in a room, the particles diffuse across the whole room.
Correct. Those particles quickly travels in the whole area. That is diffusion. Okay, correct. So it's basically spreading out of gases, or it also happens in fluids.
Yeah.
Okay, what is the medium by which diffusion process takes place? The medium by which those particles are traveling.
Medium, so gas or liquid.
That is the state in which diffusion is occurring. But how are those, where are those gas particles traveling in the room? Through which medium? What is the medium of travel?
I don't think I understand this.
Okay. So you are in a room, you've sprayed some sort of spray, the room spray. The particles will travel, come out of the bottle, they will travel in the whole room, correct? This is diffusion.
Yeah.
How are those particles able to travel? Because of what
They
is
have
present in the room?
kinetic energy.
Because of air. Air is the medium of travel. Okay? Air is the medium by which the particles will travel. Correct?
Yeah.
Now, since diffusion is taking place, the medium of diffusion is air. Do you think diffusion will occur in vacuums?
No, because there's no.
It's an airless medium, airless
Particles
environment.
in
That
vacuum
is why no diffusion will take place here in vacuums. Okay? All right. Okay. Now, there one term, if we talk about solids, then there is one term that is commonly discussed. That is solubility. Have you heard of it before? Okay. Can you tell me what do you understand by solubility of solids?
Solubility is the measure of how much a solute can dissolve in a solvent. So a solid dissolving in a liquid. And it's measured per 100 grams.
All right. Now when you gave me the definition, you took the names of two terms, solute and solvent. Can you define them?
A solute is the solid that's being dissolved, usually in a solvent, and a solvent is the liquid that the solute/solid is being dissolved in.
Okay. The solid being dissolved is the solute, and the liquid in which the solute is dissolved is a solvent. Okay. Can you give me an example?
Usually when we're like cooking and we mix sugar into our cake batter, the sugar is dissolving, and that's the solute, and then the batter is the solvent.
Okay, we'll take it. Now, you've dissolved your sugar in your cake batter. What is that formed when solute is mixed in solvent?
A
What is it?
solution.
Correct. When solute is mixed with solvent, in solvent, the product is solution. The combination which is formed is a solution. Okay. Now, when we were talking about solvents, they are liquids, right? Solvents are liquids. Please pay attention on the screen, Soumya.
Yes, miss, sorry, I'm writing it.
Okay, all right, all right. What is the universal solvent which dissolves almost all the solutes?
Water.
Water, correct. H2O is the universal solvent, correct. Okay. All right. Okay. Now I'll ask you a few questions and they will be reasoning questions. You will have to give me the reason for that statement, correct? So, if you heat a gas, what effect will this have on the movement of its particles?
A gas usually has high kinetic energy and the particles are spread out.
You're heating a gas. What effect will be there? What effect will happen on the particles? What will happen to the
The
particles?
particles will gain more energy, and the the particles will gain more energy. They can spread out more.
Okay. There will be, when the gas particles will be provided with heat, the temperature will increase and the particles will start moving here and there. Okay. They'll get some sort of kinetic energy, which will allow them to move in the environment rapidly. Rapid movement, the particles will start moving rapidly. Correct? Okay.
Yes.
Just a second. Okay. Now the second question is, okay, just a second. Okay. When we were discussing about solubility of solids, we missed one term, that is saturated solutions. Can you tell me what do you understand by saturated solutions?
Saturated or just saturation in general is when a solution's reached its maximum amount of how much a solute can dissolve in a solvent.
Can you define again?
Saturated solution is when there's the maximum amount of solute that can be dissolved in the solution.
Correct, correct. When the solute amount is maximum, in the solvent. And now no more solute can be dissolved. Okay. How will you identify whether the solution is saturated or not?
Sorry, if the solution is saturated or not?
How will you identify whether a solution is saturated or not? Means you are dissolving a solute in a solvent. It's become a solution now. At what point you will realize it's saturated?
When there's no more solute dissolving in the solvent.
Correct. As per the definition, no more solute is being dissolved in the solvent. You are stirring sugar in a glass of water. So after a certain amount is being dissolved in the water, the sugar will stop dissolving even after you're stirring it continuously. That is, at that point you will realize that the solution has become saturated now. Clear?
Clear.
Okay. So the three states of matter, can you give me three properties of three states of matter?
For solids, they are usually hard, fixed shape, fixed volume. For
Sorry.
liquids, they are random.
Okay, okay.
They
You
have
said fixed shape, fixed volume, and
hard.
they are hard. Okay, correct.
I mean, usually, like, for liquids, they have a fixed volume, no fixed shape, and are random. Uh, for gases, they have no fixed shape, no fixed volume, and they're also random.
Okay, now these were very like basic properties that you define, right? If I
Yeah.
ask you in terms of temperature,
Uh,
how will you differentiate these states?
Usually solids have the least energy, while gas particles have the most energy.
Okay. And by
So
having most energy, you mean?
the particles have the highest kinetic energy.
Okay. And that's because the intermolecular forces between the
Forces
particles
are
is more or less.
more
The intermolecular force of attraction between gases is more.
weak.
Decide one.
Uh,
Okay.
weak because they break the forces of attraction.
Solids can also break that intermolecular force of attraction. Break this word and you will get your answer. What do you understand by intermolecular force of attraction?
It's the forces between the particles within the gas.
No. Forces of attraction between the particles within any state of matter, not only gases. Okay? It's between any state of matter. Now, there are particles, there is force of attraction between them. How will you define the force of attraction?
And
If you
gases,
the paper, if you okay, okay, yeah, please go ahead.
in gases, there's a high force of a low force of attraction
Yeah,
because they're spaced apart.
correct, correct. Now you said correctly. that intermolecular forces of attraction between the gases is very weak, or you can say the weakest of all three states. Why? Because the particles are farly arranged. They are placed very far away from each other. Particles are placed far away from each other. Correct? What about liquids?
Liquids, it's in between.
In
They are
between.
weaker, but not necessarily the weakest. The
They are
forces of
weaker, but in comparative to gases, they are strong.
not the weakest, yeah.
Yeah, in comparison. What about solids?
Solids, they are strong or just stronger.
The strongest.
Yeah.
Because how
Because
are you defining
their
solids as strong?
particles don't have much space between them, so the intermolecular forces of attractions are strong.
Yeah, and that is due to the compact arrangement of particles.
Yeah.
Particles are compactly arranged in solids. All right. So I believe that most of the concepts of this chapter are clear, but I still want you to just go through the topics once, open your textbook, just check one each of the topic once, and let me know if you have any doubt.
Okay.
Okay, just open your textbook.
Miss, our next class will also start at 7.
Um, the timings will be told to you. I'm not
Okay.
aware of the exact timings right now. I'm sorry, but I'll let you. The team will let you know.
Okay. Miss, I have a request.
Yeah.
Sometimes my computer is not available to me, so could you send the meeting ID to the number? My number?
Okay. I'll convey this to the team.
Okay.
All right. Yeah. Now, please take 5 minutes with your textbook and let me know if there's any topic which is left ununderstood or you have a doubt.
From chapter 1?
Yeah.
Okay. This next lesson will we start the new chapter, chapter 22, because that is the current unit I'm doing in chemistry now in school.
Okay. So you're doing chapter number 22.